Alors, nous reprenons évidemment l'aspect scientifique du colloque avec un regard croisé d'experts autour des questions de big data et de création de valeur pour les retailers. Ça va être notre petite minute qui va durer 1 heure internationale, puisque nous aurons donc un échange sur cette question en anglais, animé, c'est un regard d'experts, donc ils vont se parler l'un à l'autre et évidemment vous parler également. Nous avons donc le professeur Ed Malthouse que nous avons accueilli déjà ce matin, directeur donc, de la recherche au Spiegel Research Center et professeur à l'université de Northwestern, et mon ancien collègue et toujours ami Christophe Benavent, professeur à l'université de Nanterre et également directeur scientifique du pôle digital, je pense, à l'Obsoco. Voilà, donc je leur laisse évidemment la parole pour cet échange. Alors, ça sera évidemment un échange de très haute volée, on va dire, sur les questions de big data. Donc, pour que nous puissions tous nous suivre, je leur ai demandé de temps en temps de faire des petites slides, parce que comme ça permet de fixer un peu les choses pour nous, qui sommes évidemment, en tout cas en ce qui concerne, beaucoup moins experts et calés sur la question. Merci encore à eux d'avoir accepté de partager évidemment toute leur expertise sur cette question.
We will start with that. Just a general view of what means big data. Big data, you don't have to think to it as a static thing, a very big database. Big data is first a process, the start. First, by a capture process of information that came from the market. We will give more details about that. Some data that are captured. So the first step of the big data process is, of course, are you able to capture reliable and relevant data from the market and through, mainly today from that, but the IoT and other devices will be very important. They are collected, they are stored in the cloud, generally speaking. The biggest issue today certainly is how you modelize the data. And there is a clear revolution for marketers in this field. New methods like machine learning, deep learning, and other methods are going to grow up very fastly and need technical competence. That's a personal message to marketing, to marketers, academics. You need to invest in quantitative analysis. You need to learn R or Python. We need a strong move from qualitative survey to purely quantitative survey, because that's the nature of the relationship with the customer. When you are able to build this kind of model, you need to disseminate the information. And today the point of contact is there. Individual people with the screen they have or other device. Of course, their behavior induced by all this process will interact at the market stage and mainly in a landscape which is a platform landscape. That means markets are not just buyer and seller, but more and more are interaction between different group of customers that play a role of producer or customer in the same time. So that's a broad view, and we will develop on each stage of this process. That will be certainly one of the best way to apprehend what is the process of big data.
I'll just add one comment. I agree with everything Christophe said, but I think the key factor with big data is that we spend more and more of our lives in a digital environment. And so whenever we're in a digital environment, our every behavior, our every action can be recorded. And the economist called this data exhaust. You know, so when I'm on my mobile phone, when I'm on my computer, when I'm using a car that's connected to the internet, there's a trail of data that records my every action. And so that's what big data is about. What big data is not so much about is my thoughts, right? So traditionally we have studied how attitudes affect intentions, affect behaviors. With big data, you're starting at the end of the process and you're starting with the actions, and you have to think about what the consumer is thinking. Go ahead.
Go ahead. At the next point, it was your tour.
Yeah, all right, well, I can talk about this.
Okay.
So, one of the big issues that comes up when you have observational data, so you're just observing actions on customers, is with data quality. Okay, so I have a saying that you should never trust data from anyone, because the way it was collected could, create some biases. So Christoph and I have a couple examples of biases for you. I'll share a bias, then he will share a bias. So this is some work that we did on customer reviews, and this is one of the key pieces of data that we were explaining in this paper. So we were looking at a retailer that sold health and beauty products. So think of shampoo, lotions, vitamins, all sorts of health and beauty products. And we had their customer reviews for many thousands of items. So this is a big retailer selling thousands of different types of shampoos and lotions and everything. We also were able to scrape data from Amazon in the same category. Now, what was very interesting about this data set was that there are two ways to write a review. Okay, so if I am a customer and I order some shampoo, next week they will send me an email saying, write a review about the shampoo. Okay? Now, the second way that you can write a review is you can go to the website, you can search for the product, and you go to the page, and then sometimes you have to create a login. You create a login, then you're allowed to write a review. Okay, so I call the one case is an email review, where they send me an email, I click on 5 stars, 4 stars, maybe type a few words, versus a web review where I go to search, I create a login, and I do all that. So what we did was to track the average star rating as a function of the number of reviews. Okay, so at the far right, you have a product, with one review. The average for email is about 4.5. The average for web is like 4.2, 4.3. Okay, now when a second review gets added, now we have 2 reviews. You can average them, and this would be this. All right. And so, 2 things to notice. Number 1 is that the email reviews are systematically more positive. And we've looked at this across different categories. This is health and beauty. We looked at light bulbs, and there was a 0.5 point difference between the email reviews and the web reviews. All right, so that's point number 1. Point number 2 is that the reviews become more negative over time. Why would reviews become more negative over time? All right, so as you get the 20th review, it's more negative than the first review. Okay, so our explanations for these are as follows. First off, you have 2 different populations. Who's going to go through all the effort to find the product, to create a login, create a password? Oh my God! It's the person who's angry, right? If I'm happy with the product, I'm not going to bother with that. So you're really fundamentally tapping into a different population that's systematically more dissatisfied with your product. So it's a very different population. But that doesn't explain why it becomes more negative. Our explanation for this is that you have a self-selection bias. So let's say I go to the shampoo page down here, and I'm happy. I like the shampoo. I see many other reviews that are happy. I see some that are not so happy. I'm not going to bother because everyone has already said the positive things that I want to say. So I opt not to write the review. Now, on the other hand, if I'm angry, of course I will take the chance to write the negative review, and that is why over time you systematically remove the positive people. So that's one example of biases that are created through this data collection that is really it's just a complete convenience sample. I'll just mention one more thing. If you're a retailer, I think what you want to do is get a good representation of your customers through the reviews. And these web reviews, I think, are very questionable. So you're much better off sending out emails to a representative group of your customers and relying on those reviews rather than something that's more systematically negative. I know Christoph has another example for us.
Yes, in the same area of reviews. So you understand that the first problem with big data is that data are not given, they are produced. And to have a good control of the process, you need to know how these data are produced. In the case of reviews, we have the same thing. This is a classical survey, a poll survey. We ask just two questions. What are your motivations to publish a review in the tourism industry, that could be in retailing? And the second question we ask is how much you publish post and review on internet, on TripAdvisor, for example. So here you have those people who publish just one time. We don't observe those who don't publish, who are not interested in them. But, of course, they represent 95–98% of the population. Just a few, 1–2% produce review about, so we could ask, do they are representative? And here, of course, those who publish often, that means 10 times during a period of 6 months, okay? And we ask the motivation. And when you look at the profile of motivations, you see we have completely different profile. There are three main motivations. The first one is a kind of egotism. People publish because they are viewed by other people and they want, so it's a selfish attitude in a certain sense. That's the blue line. And you see a very strong increase from category to category. Correlate to that, but in a less extent, you have the expectancy of reciprocity. Some people do it morally. I was helped by others in choosing my destination, so I want to give back the help I receive. And you see that these two are more or less correlated. They work together. A little remark, human being is not egoist, is not altruistic, is clearly a mix of the two. And the red line is the desire of vengeance. So people want to retaliate when they get a bad experience. Okay, so you could imagine that in this case, those people will produce more positive review, and the people who are there produce more negative review. So now do some arithmetics. Imagine you have a population. The true population is 50% satisfied, and the other half is not satisfied. But imagine that those people publish just one time, and those people publish 10 times. Result, the production system of review will produce 80% of positive review against 20% of negative review. You see clearly what is the challenge when you deal with a big data process, when consumer produce and you don't control this process of production.
Just another really short example of biases. There's a lot of excitement about Twitter because it's easy to scrape, but that doesn't mean we should trust it. So there was a hurricane that hit the East Coast in the United States a few years ago. And the news media got very excited because there were millions and millions of tweets coming from New York City. So the inference was, well, of course, the damage must be very bad in New York City. When in fact, the damage was much worse south of there in New Jersey. So then why would you have so many tweets from New York City? Well, because lots of people live in New York City. All right, so you have to be extremely careful because there's no sampling, basis here. There's no random sampling time. Christophe, do you want to take us through our framework here?
Yes. So the next step will be. Why you don't? Okay. Oh no, it's yours. Your turn.
The slides got sort of jumbled.
We try to prepare together, but this morning, so
this is another.
We miss a few minutes of preparation.
Another example of a problem with big data. This is from the New England Journal of Medicine, which is the premier journal in all of medicine, and this is actually a joke. Okay, so it was a joke. The editor was playing on journalists. The editor got so sick of people just reporting correlations. If you eat this food, you are more likely to have a heart attack. Not controlling for anything else. And the problem with big data is, so many of the techniques find associations, but that doesn't mean we have causation. So in this case, they published this graph saying, look, if you consume more chocolate, you have more Nobel Prizes. And they were extremely careful in their analysis. They did a test on the correlation. It was highly significant. And of course, this is all nonsense, right? What's implied is there's causation, when in fact there's really some third variable that's driving both chocolate consumption and Nobel Prizes. So just, in addition to the sampling problems we have to worry about, correlation is not causation. You all learned that in your first stats class.
Yes, we could just add for the precedent slide that the phenomena that Ed has shown is a classical one in sociology. I mean, I guess everybody has read the paper of Robinson in 1951. That's a clear example of ecological correlation. The third variable, of course, you find it, is just the wealth of the country, which is the cause of the Nobel Prize and the cause of the chocolate preference. When you aggregate the data at the level of the state or certain geographical level, you find correlations that in fact don't exist at the individual level. The classical example was about literacy of black and white people, and the fact that there is no correlation between the race in USA, it was in USA, and the level of literacy, even at the state level or even at the district level, I don't know, but another level, a final level, there was a clear and strong correlation. So that's one of the problems. Just for the story, just remember that when Robinson published his paper, that was the end in sociology of using secondary data to analyze social phenomenon and that opened the era of the Gallup, of sondage and other polls, because they realized that it's very important to work at the individual level and never, or be very careful when you work at the aggregate level. In a big data context, there is a clear issue about that, especially in Europe. In Europe, we have the RGPD, the new regulations, that make it difficult to work at the individual level. Companies will be obliged to anonymize their data set, and sometimes with the movement of the open data, want to try to aggregate data to escape from the privacy problem. But if you aggregate your data, you could produce wrong correlation and spurious correlations. But there are some advantages in big data. We don't want to be too much critical about it. And one of the advantages, we didn't talk about little things. Everybody has some knowledge in statistics and polling, and you know that when you have a 10,000 sample, you never need more, because at this size, the sampling error is less than 1%, and so the precision is enough. So why gather several hundred of thousands of data or even millions of billions. You will not improve the precision of your analysis. But what you can do once you have a lot of data, it's not a really big data, but it's a lot of data. Quietly, 1 million of questionnaire about satisfaction in the retail industry. If you do that, you could do some kind of meta-analysis. There are some other modeling approach, but here it's simple and clear. That's my equation. So satisfaction depends on quality of merchandising, the assortment, the employee, and the commodity of experience. Okay? And I try just with a regression model to model the impact of each factor on the global satisfaction. So it's very, very classical. But in this case, the survey was done on 500 different outlets. Okay, so I was able to modelize outlet by outlet and to work not on the original data, but to work on the parameters. That means each graph here represents the distribution of the parameter, but not of the variables. And we could do some meta-analysis on that and have a finer approach of the phenomena. Just one example here, the role of merchandising in this company. You observe that there is a linear and pretty strong correlation between the parameter, that means the importance of merchandising, and the size of the outlet. In small outlet, of course, we understand that merchandising is very important because assortment is not enough and that create a better experience for the consumer. But this factor is less important in big outlets that attract people who are more interested by the assortment and not by the facility to find what they want. So one very good advantage of big data is to have this more contextual approach of phenomena.
So we're talking about how we can use big data to make better decisions, and I think Christophe just gave an excellent example where you can multi-level sampling and study how consistent it is across those different levels. I think a very important question that you must answer is, what are you trying to do? Okay, so, and there's two answers to that question, two broad answers, and there's actually a continuum between them. But on one extreme, you're trying to assess causation. You're trying to make a prescription. If you do more of this, you will get more revenue. If you eat more chocolate, you get more Nobel Prizes. That would be an example of a prescriptive statement. All right. Which of course, on the other hand, you have pure prediction. Pure prediction is where you're just, think of speech recognition on your phone. You're just trying to associate certain patterns of your voice with words. You're not trying to interpret causation or anything like that. So what I thought I would do is give you a quick example of how you can do good causal research using big data. So this is some work that I did on mobile shopping apps. Have any of you seen this picture? Very famous picture. It's in the Korean subway, in the Seoul subway. And what Tesco did in Korea was they bought all of the advertising space between the cars. So you can see here's someone's getting in the subway, someone's getting in the subway. This man is doing the shopping. So he takes out his phone, he scans a QR code, and then tomorrow there will be a box of groceries at his apartment. All right, so we worked with a grocer in Chicago. This is the local version. This is the our train system, and if they had to copy the Tesco, and so this was an announcement of this new shopping app. So this company Peapod is an online grocer. So you know, for 20 years you could buy your groceries online and they would show up the next day. In 2013 or so, they launched a mobile shopping app like the Tesco one. All right, and so this billboard was just announcing this shopping app. So they came to us, actually before I get to that, they came to us with really two questions. If we get someone to download this app, do they become a better customer? Okay, so you can argue that it's easier, less friction. I can be anywhere. I can be on the train and remember that I'm out of noodles. And I can add that to my shopping list, and then, whenever I hit send, I get it. So I'm always with the grocery store if it's here, right? I can wake up in the middle of the night and add coffee to the list. All right, so do I become a better customer, a more loyal customer, because I download the app? So that's a causal question. Now, there's a second question, which is, tell me about devices. Do people use this device differently than this device? What can we say about that? And, we didn't really have any theories on that. But the point of this is that you can use big data to make inferences if you're careful. So what we have here is a natural experiment. At some point in time, they launch the app. You have people, current customers who adopt the app, and that's your treatment group. There's another group of customers who decide not to adopt the app, and that's a natural control group. Now, we used a technique called propensity scoring matching from epidemiology, where for everybody who self-selected into the app, they chose to adopt the app, we try to find a twin who didn't adopt the app. So they bought exactly the same sorts of merchandise, because the problem you have is the people who download the app tend to be your better customers. Yep. So you have to find other better customers who chose not to download the app to get a true comparison. Okay, so that's rule number one. If you want to do causal inferences, you have to think through those issues of selection biases. Then what you have, you have the advantage of a time series, and you can make comparisons like this. For example, these were their order rates. How often did you order groceries prior to adopting the app? Then this is what happened in a post period, so after they adopted the app. Now, let's just take a look at this top line, and what you're going to see is that the top line is flat. Okay, so these are people who adopted the app, and you can see, well, it looks like their order rate did not change. However, those who did not adopt the app, that's this other line, their purchases actually went down because of seasonality. This was a period where people were doing more, cooking at home. There was a period where maybe they were going out more, something like that. So the point is, you can assess causality by having a good control group, and diff in diff is the term that's used. So basically, what you'll see is that order rates went up, so people buy more often. Basket sizes increase. So when I go shopping, I spend more money per basket. Real quickly, there's a multi-channel story. It turns out that people who are only using the mobile device are the weakest customers. But the customers who are using a PC with two mobile devices, so they're with you on their phone and on their tablet, are the best customers. So I don't think there's anybody in this room surprised that multi-channel is really important, but that's something that we found. I'll just mention one more kind of interesting finding. So the third question was, do people use this device differently than that device? We weren't sure, so we were just doing some exploration. And it turns out things like coffee creamer over-index on this device. Seltzer water over-index on this device. Things like body lotion over-index on this device. So, what do these things have in common? Well, we came up with a hypothesis that anything that's habitual, you want to buy on this, because the screen size is very small, it's hard to navigate, much easier to make comparisons on this. So, coffee creamer is a very simple product to me. It's something I drink every day. I'm out of it, send me more. Okay, I don't need to think about it. But I look at my wife when she buys body lotion, and it's a very complicated process. So there's certain ingredients that she's allergic to. She doesn't like these smells, and so she needs to do extensive research before she puts that in the shopping cart. It's much easier to do that on a screen that size. Think about booking a holiday where you want to compare different options. You want to have a screen that size. You don't want to have a screen that size. But if this is the only screen you've got, you'll use it. I think Christoph has another example.
Okay, something a little bit different. We talk about some regression model at a big, large scale. I didn't talk about, for example, SVM, support vector model. There is a large variety today for doing that. All this random tree forest. All these models are classical. In the sense you have dependent variable and independent variable, and you try to predict something or to explain something. But modeling is not limited to that. Just one case and example. How you could optimize your display campaign. You don't have a lot of data except the click-through data. You know that someone has clicked on a display or not. That's all. And how we could optimize a campaign with that. We need new family of model. We don't know very well in the field of marketing. One example of this is model MAB. MAB is multi-armed bandit model. You play at the casino, some of you, and the machine à sous. So the strategy, how to beat the casino. Or just to limit your lose. Just to limit your lose. The strategy is very simple. You take your piece of money, you put one in one bandit, then another one, and another one, and another one. When you visit all the bandits, all the machine, you do the same, etc., etc. And you record the statistics. And of course, you will learn slowly, and you will focus on the machine who give you the best yield. That's exactly what do this kind of algorithm. So on the right, that's the situation. There are different slot machines, A, B, C, and the pulp will try all, once after once, and record the success. The octopus. The advantage of big data is you have millions of clicks, and so you could do more than just 8 arms, but you could use 100,000 and more different arms to optimize your plans. And the learning process is here. Of course, people from operational research and mathematics, they work a lot on that. We have in marketing to read paper from mathematics, etc. Just a little joke. My main review today is the archive. The platform for physicists and other mathematical science. There are more interesting papers in marketing in this platform than in most of all other reviews. But it's just to kid a little bit. So here, that's the results. The different repetitions, so that's the time process. And you have the result of the different strategies. The basic one I give was a naive model. There are some interesting model, the greedy model, for example, the E-greedy model. The E-greedy model is just to make a decisions between the naive model and to come and and another part of the data you concentrate where you observe a better performance of some slot machine. I don't want to go more further in the different kind of model, but that's a completely different way to appreciate what is a model in marketing today to optimize certain issue.
Another great example of using big data. So I mentioned that there's, on the one hand there's causation, and on the other hand there's pure prediction. So I thought I would give you a completely different example where I think pure prediction is a legitimate goal. Machine learning often gets sort of a bad reputation, especially among academics, social science academics, who say, well, it doesn't do causation. Well, here's a situation where you don't really care about causation. So this is some work I actually did with some people just up in Ghent, so very, very close to here, on crowdsourcing. So there are many examples where firms and retailers try to involve the customer in creating value. Okay, so one way that customers can help create value is in coming up with new product ideas. And so one example of this is Starbucks has a website called My Starbucks Idea. And what I'd like to draw your attention to is that there's a lot of ideas. So many people care passionately about their Starbucks coffee and they want to make it better. So in fact, there's nearly 50,000 ideas that have been submitted by normal consumers only on coffee and espresso. Okay? And then you can see there's another 25,000 ideas on food. I like my muffin differently. Another 12,000 on merchandise and music. I don't like the music in the Starbucks. All right, so the point is you have a lot of ideas. Another example of this comes from Dell. Dell has this Idea Storm site, and you can see that they have over 35,000 ideas submitted. What I'll point out to you is that they're also involving consumers in evaluating the ideas. So it says here there were 759,000 votes. Okay, so if I'm a Dell customer, I can go to the website and, if Christoph made a recommendation, I could vote for his idea. I like his idea. And you can see that they've implemented over 449 of these ideas, just showing that they're listening to the customers. So you get an example of what one of these ideas looks like. It's usually text. Okay, so text is unstructured data, which is a problem for our classical multivariate analysis methods. We happen to look at a site called Mendeley. And so Mendeley is this system that helps people who do a lot of writing with their bibliographic references. And you can see here's an idea that got 3,000 votes. All right. So we had a couple of questions about this. The questions involve how well we can scan through all of these ideas. So if you have 100,000 ideas like Starbucks has, you would need an army of people reading these ideas to evaluate them. So what we need is a machine learning algorithm to scan through all of these ideas and select the good ones that would then get passed on to our product development team. And they would be able to evaluate them. So we need something that's at least a rough first cut to get rid of all the bad ideas and just focus on the good ones. Now we talk about 3 C's. So the 3 C's refer to what you know about the submission. So the first C is the contributor. What you're going to find is that some contributors are very loyal. They will come and give you, 10 ideas over time. And this person has submitted 10 ideas before versus this is a customer who's never submitted an idea, this is the first idea. You also know something about their history. If I've submitted 10 ideas and all 10 were bad, that might signal to you that this is another bad idea, so we should just throw it out. On the other hand, if I've submitted 10 ideas and 3 of those ideas were adopted, that might signal to you that you should listen to me, right? So we can have all sorts of variables around the contributor. The second C is the content. Okay, so the content is exclusively expressed in text. It's a written paragraph. On some sites, it gets more complicated because sometimes you can upload an image, okay, which is another form of unstructured data. And that's in the future. We didn't have to deal with images, so we were only dealing with text. So are there certain patterns in the text that indicate this is going to be a good idea or a bad idea? Another really key thing that we identified was a way to characterize novelty. Okay, so there's a continuum between very incremental ideas. We're going to add a little more cream to the coffee. That's a very small idea versus a very bold idea that has never been seen before. So what we did is we clustered these ideas And so you find that there were ideas on this topic, and this topic. So if a new idea comes in and it's very similar to a bunch of other ideas, we say it's an incremental contribution. If it's very dissimilar from all the ideas that we've already seen, we call that a novel idea. So novelty is part of the context. The third C is the crowd. Okay, so this is what the rest of users are saying, and so if there's a lot of positive votes versus negative votes, that's what the crowd is all about. Now, one more thing to notice is at the time of a submission, so I submit an idea, you know two of these three things. You know the history of the contributor, and you know the idea, and so in real time, you can use those two pieces of information. What you have to wait for as an organization is the crowd. And depending on how much traffic your site gets, you may have to wait several weeks before the crowd has fully weighed in on whether this is a good idea or a bad idea. And so we wanted to find that out. And my point with all of this is that this is a situation where causation is not really the issue. It's about predicting which idea is going to be worth reviewing further and which ones we can throw into the garbage. All right, so we use data from Mendeley. Whenever you build one of these data sets, Christoph's going to talk more about this, you need a good training set. You need a training set is something to train your machine learning model on. So we look backwards, and some ideas were submitted and got rejected by experts. Some ideas were accepted. So that gave us a training set. So we're going to try to predict whether an idea was accepted or rejected based on these three classes of variables. So we tried a whole lot of in machine learning. Basically you try a dozen models and see which one works best on a test set. And to kind of get to the punchline, it turns out. The crowd is really important. So having a lot of other customers' eyes on this idea is very important. And once you bring that information in, your ability to discriminate between good ideas and bad ideas improves substantially. However, without the crowd, you can still do an okay job. And so in other words, you can, in real time, throw out certain ideas because they will be bad, and you can do that with just this machine learning algorithm. I know Christoph has another example. No, we don't. Yeah, you're up.
I don't remember. So, okay. Well, that's a very important point that Ed has underlined. The status of model in marketing and in big data. There are two statuses. There are general model for general knowledge, as a regression models. A models is a representation of the theory that we apply to the reality to test some hypothesis. But in the field of big data today, modeling is not to understand what happens, is to act, is for actions. We have model for actions. And we didn't recall the three V of big data. V is understandable for everybody, V for volume. So what is big data? Is it 1 million, 10 million, 1 billion? I don't know. Even a few hundred of thousands start to be big with our experience of data analysis today. So volume is not very important. Variety, you had a little test about it. Variety, that means we need to process not only numbers, but also text. And there is a pretty big challenge in text analysis with really a creativity which is fantastic. Just mention the word-to-vec model, just mention all these topic model like the LDA you saw before, latent dirichlet allocation model, all this kind. And the third element, of course, is velocity. That means a model must work in a fraction of a second. The time is not 1 second, is less. When you implement a model, the response must be immediate. And just a little case to explain this idea. The case of Flickr. And one more idea we need to have in mind the strategic problem of the company when we develop a model. The meaning of model for action depends on the strategy. You know Flickr, which is a picture platform. Their basic model was a freemium model. That means a small part of the population accept to pay to get some services to stock, manipulate, edit, and share their picture. And it was not a success. And they decided to change their business model and to go to a completely free model. So today, if you take an account on Flickr, they give you 1 terabyte of free space. It's impressive.
Is it a lot?
Huh? Yes. Not my dog. This one, no. This is not my spider. Louis Bourgeois. But all are my picture and my accounts. And how to make money with that? We are in a multi-side model. There are some people who are not the customer but the contributor. They give the pictures. And there are some other people, ad agencies, news agencies, that need pictures and want the picture for just a little model. But the problem is that most of people are lazy and they don't documentate their picture. They don't give titles, they don't tag it. What has done Flickr? They bought on ER startup, specialized in object identification and picture to systematically tag the picture you put on that. So you could see here animals. That's my picture in my account, just a little sample. What are the animals? What are the pictures which are labeled animals? I didn't do that. I didn't do nothing. The intelligence do it for me. What's that done? That transform the picture as searchable picture. Because now they are labeled completely, 10 to 10 labels. I think they use now quietly 1,000 different categories. They are able to identify in one image more than 1,000 objects and tag them. Of course, that makes the picture searchable and the business valuable. That's a very good example of how modeling could improve action.
So, I think we have a couple minutes left. 2 minutes left. So, we were just going to mention where I think a lot of this is going in retailing as platforms. So, here's a short advertisement for tomorrow. I'm going to be talking about some data that I have from a multi-sided retail platform, which to me is unthinkable a few years ago, where 180 retailers in the U.S., big department stores, have banded together and are joining a platform to be joined with customers. And we'll be talking about how to manage such a platform tomorrow and what we found with the data. I'm also going to be talking about multi-stakeholder recommendation systems. How do you recommend brands? You got all those brands. How do I figure out how to recommend which brands to consumers, taking into consideration the utility of the user, which is the traditional recommendation system, and also incorporating the utility of the retailer, this other stakeholder in this. So that's tomorrow. And I know Christophe was going to mention some other multi-sided platforms.
Yes, it's a kind of conclusion. So you have an idea of what we think about is big data, but I think we need to come back to the strategic level and to understand the landscape. So what is the landscape today for retailing industry? It's not a question of relationship between the retailers and customer. That's the end of that. I think we are quietly at the end of relationship marketing. Of course we need that, but it's not enough. It's not enough. It's not enough. Why? Because who are those actors who are able to process this kind of data and to develop the infrastructure to exploit them? And for now, we have just a few very good players. And it's interesting to look at the strategy of some company. My best example for me is the case of IKEA, that first opened some outlet in the Amazon website and take position in the platform landscape. And secondly, second event that was very important, they bought last summer TaskRabbit, which is a platform that make relationship between people who are good in bricolage. I don't know the name in English, you can translate. Handyman, okay. And of course, consumer. We know that very well. Philip, with the Obsoco, we have done a very big survey about that and behavior of consumer last year in this field. And so studies the situation in France. There is a case of Frisbees that you have visited yesterday. That's the same kind of company, but TaskRabbit is very big, and IKEA bought it for $1 billion. Okay, that gives you. So the strategic issue today for retailer is to ask themselves: do we have the capability to settle this kind of logistic of data for our own needs? My belief is that they are not able to do it. And they need to cooperate and build strong partnership with the good actor on the market. Of course, the choice is limited. It is between Google and Amazon mainly, but certainly we will have some other actors. I see some specialists of these things that grew up very fast. So that will be my last word. Do you agree with me or not?
I think we agree on most things, so it's been fun working with you.
Alors, ils ont été passionnants, ils ont évoqué plein de sujets à propos évidemment des enjeux du Big Data. Je pense qu'on peut prendre une question, et après il y aura vraiment un temps d'échange évidemment pendant le déjeuner, et s'il y a une question dans la salle, on peut quand même la prendre.
I think it will be difficult in English, but I will try. So my question is, there is a link, or is there a link between big data and fractals? I don't know if you know the fractals, yeah?
Fractal geometry.
Yeah, so my question is simply how big data can help companies to make the link between the particular and the global, and how can we make it real in retailer process? How big data can simplify the process by using fractals or something like that.
En une minute, oui.
I'm not aware of any research, but it may exist between fractal geometry and
I have something in mind. Some people have done that to prevent some risk, and they use seismic modeling to predict the apparition on an event. And what is interesting is that the data for seismic analysis is multi-layered and certainly has a fractal structure, and they try to analyze the different band of frequencies of the signal before to make some prediction about that. So we have just, I think to that, tried to read the literature which is far larger than just management, to get new ideas about how we could modelize some marketing phenomena.
Merci encore. Merci à la